Alright, so the question is, work with your team to find two different ways to solve x minus 2 to the power of 2 plus 4 is equal to 2x plus 3. Be sure to explain the logic of each of your methods and show that the solutions are correct. Alright, so breaking down the equation at first, you can see that the first part is a quadratic and the second part is a linear, and the quadratic is in vertex form and the linear is in y equals mx plus b form. Now how do we solve it? There are two different ways we can solve it, and that's algebraically and graphically. So starting with algebraically, we look back at the equation, and as you can see here, there's the x minus 2 to the power of 2. You can distribute the power of 2 into it, which gives you x minus 2 parentheses x minus 2 parentheses. Now what you have to do right here is use the flow method, which gives you x to the power of 2 minus 2x plus 4. Then you plug back in the rest of the equation, which is the plus 4 right here, is equal to 2x plus 3. Now what you have to do here is combine the like terms, so the negative 2x's combine to make a negative 4x, and then the positive 4 is combined to make a positive 8, and after that you have to make the you have to okay, so it leaves you this equation. Then you have to take the positive 3 from both sides, or you have to take the positive 3 from this side and subtract it from both sides, because what you do to one side you do to the other, which leaves you to x to the power of 2 minus 4x plus 5, because that's where you subtracted the 3 from, is equal to 2x. Now what you have to do after that is subtract the 2x from each side, which leaves us to 0, and since this is already negative 4x, it makes it negative 6x. So then what you have to do is factor it, because it is a factorable equation, so it comes out to x minus 5 parentheses, x minus 1 parentheses, which gives us the x values of 5 and 1. And we got this by setting x minus 5 equal to 0 and x minus 1 equal to 0. Now, what you have to do is you have to take these values and plug them back into the original equation, and what we're going to use is the linear equation, because that's easier, and easier is always better. And what you get is 2 times 5 plus 3, so 2 times 5 is 10, plus 3 is 13, so that's the first one. And then 2 times 1 plus 3 is 5, and that's the second one. And these actually give you your y values of 13 and 5, which gives you your intersecting points that we're going to need later of 5 and 13 and 1 and 5. So now like I just said, they are the intersecting points. Now we move on to solving it graphically. So as you can see here, we're going to start with the linear function, which is 2x plus 3, or y equals 2x plus 3 rather. And what you have to do is you have to find the slope, which is right here. And when it's not in a fraction form or has a number below it, you automatically assume it's 1. So the slope is 2 over 1, or rise over 1. So it rises 2 and moves over 1, and the y-intercept is 3 right here. So on a graph, this is what the linear function would look like. You have, see, the y-intercept right here at 3, and then it moves up 2 and over 1, moves up 2 and over 1, moves up 2 and over 1, and then it moves down 2 and over 1, because that's the opposite. Alright, now we have to move on to the second part, which is the quadratic formula, which is in vertex form, so that means it has h and k shifts, and the a is 1, so that means it is going to be facing upwards rather than downwards, and it would be facing downwards if it was a negative 1. And a also controls if it's going to be stretched or compressed, but since it's 1, which is a very which is a neutral number, it's just going to be like, it's neither going to be stretched or compressed. And now we have h, which is negative 2, and that controls the x-axis. But you plot the opposite number, so the negative 2 is actually 2, and then the k is the y-axis, which is 4. So your vertex is going to be at 2 and 4 right there. So our final graph is going to look like this. Now, and then you're going to have the little arrows at the top here because the parabola is going on forever. So as you can see here, the intersecting points are a 1 and 5, which is what we had before, and 5 and 13 up here. So that's how we know that our graph is correct, and the answers we got before algebraically was correct. So for the real world connection, there's intersecting lines everywhere. If you're a roller coaster person, if you look at the trusses on a roller coaster, as you can see here, they're always crossing over, and they make an X, and they'll make X's. Or if you, or like even if you're an architectural person, you see the trusses of a bridge here are also always intersecting and crossing over. So, like in the real world, there are a lot of intersecting lines, especially in trusses when you're on roller coasters, because if you didn't have those trusses, you would most certainly die from trying to ride the roller coaster because it would collapse, and yeah, that would be horrific. Anyways, I hope this video has helped you with your various problems in math, and Patrick, signing off.